Welcome back. So here we are. We're in the last video, 7-5, Module 7. And we've covered a lot. And we'll do a little review on some key concepts. And then talk about things outside the scope of this class. Things that you may see down the line depending on what you do. So up to this point in this module, we dealt with tuples, we dealt with lists, dictionaries, and sets. Now tuples and lists are very similar. One's mutable, one is not. Dictionaries and sets are quite similar. They both use curly braces. One has keys and values, the other only has keys. Lists we use square braces, and tuples we use commas, and we can use parentheses, but they're optional. As I said, dictionaries have keys and values. Keys must be unique. Sets only have keys, and those keys must be unique. So there is no duplication in sets. Now, if we're talking about tuples, lists, dictionaries, and sets, they can all have a variety of different data types in them. And by that, I don't mean that you can have all integers or all floats or all lists or all strings. I mean, you can have multiple data types within the same structure. Okay. And sets are automatically ordered by the system in some kind of way. So we'll leave that there and move on. Okay. So from that, let's go look at an array. And the data structures that we've dealt with so far, back at the beginning when before I talked about a tuple. Way back here, talked about scalars and vectors. Scalar, we talk about something in magnitude or numerical value alone. It's one-dimensional. But a vector is not just numerical. A vector, we tend to look at it as a one-dimensional array. Okay. An array is different than a list. And there's a few ways that it's different. Primarily, an array, it has an index. So we have that's from 0 on till length minus 1 are the indices of an array. But if we think about a list can have multiple data types. An array contains a single data type. Now, there are multiple data types that can be stored in there. So I can have an array of integers, I can have an array of floats, I can have an array of strings, I can have an array of objects. There's so many different data types that I can put in there, but whatever I put in there, they all have to be the same data type. That's a big deal. That's a big deal. And as long as we know the rules to the game, we can play. So, I'd said before, I think I gave you an example, that Python does not have a built-in array class. But we can import Numpy and use an array class that is built into the Numpy library. So Numpy is a library of code that has a number of different classes in it. And all I have to do is import it, and I can use whatever's in there. So let's go look at some code that I've got here. And Let's start out, let's declare some lists. So here's two lists. This is something we've done previously. Declare a list, square braces, and store it in some variable location, so it's stored there. These have an index 0, 1, 2, 3, 0, 1, 2, 3. I can treat sales and profit as two parallel arrays, or I should say in this context, two parallel lists, because at this point they're lists. That's the data type. So I stored these values in the variable. I can use a for loop to go through both of them at the same time. So I go from 0 to 4. Well, I stop before I get to 4. I don't actually do 4. So it's 0, 1, 2, 3. 0, 1, 2, 3. And every time through, I go through 0. I is 0 the first time. I is 1 the second time. 2 the third. 3 the fourth. And then I'm done. And it takes I and it uses it in place of the index. So it's the index, what I'm pointing to there, the value of the index in this list is a variable. And I'm using that loop to navigate through that structure, one item at a time. But I'm actually going through both of them. I'm going through profit and sales. And when I go to profit 0, I'm also in sales 0. So if there's a relationship between these values that they are parallel, this is how we go through them. I'm at the same position, same index on all of them, and I'm not limited to just two parallel structures. I can have as many as I want as long as that relationship exists, and they need to have the same amount or same number of indexes, or they need to be the same length. So with that said, we went through this loop, performed the calculation, and on each iteration of the loop, we printed out the result of that calculation. It's a great way for us to manipulate and navigate a list. Well, not just a list, I can do it with an array as well. Because as I said, in a list, we can have all kinds of stuff dumped in there. In an array, I cannot. So let's use the same context of what we did here in a list, and let's go make arrays based off of those lists. So I had a list named sales and a list named profit. Here it is. I took the profit list, I typecasted it using the Numpy array function. Okay, so Numpy has this array class, and when I imported Numpy as NP, I'm now pointing to that functionality built into Numpy. So that Numpy library has this array class in there. And then if I don't use Numpy, if I don't import it, I don't have the ability to use that array class or create array objects in Python. And so why would I want to have an array when I've already got a list and the list works fine for me? I did it up there. I'll show you. We'll get there. So in these lines of code right here, I took the lists and I typecast them to be arrays. So now I have a profit array and a sales array. Quite often, you will see where people have put the data type in the variable name. Profit list, profit array. That way you know what you're dealing with at a glance and don't have to go run some code or mouse over it to see what data type it is. So then we print the data type of that array. We see it right here. It's an instance of the class Numpy ND array. Let's print the array itself. Well, there's the array. Well, wait a minute. That looks just like a list. Square braces. They're treated the same way. I did the same thing with the other one. And then I did a calculation down here with the two values. Oh, I ended up with the same values, but it's in a list. The result of those values as I iterated through them created a list as a result. Okay. Now, an array can be one-dimensional, or it can be more than that. We're going to see, and I've talked about it before, we're going to see these structures referred to in different ways. A string is a one-dimensional array. A list is a one-dimensional array. A vector is a one-dimensional array. A chart in Excel, it has height and it has width. That's two-dimensional. And that structure, we can create a two-dimensional array, but you can either say it's a two-dimensional array, or we can go up to n dimensions, so n-dimensional array object, or we'll use the term matrix or matrices. So let's go look at matrices. So a matrix is two dimensions, specifically two dimensions. And it's an instance of an array. So here I do the same thing that I had before. I create three lists. I take those lists and I pass the three of them to that Numpy array constructor. That's that function that helps me create this array. And then I store them in this matrix. And it's like, oh, wait a minute. I see three things there. Does that mean it's three dimensions? No. No, it doesn't mean there's three dimensions. Just because we're passing three lists does not mean that it's three dimensions. The dimensions that we have are height and width, or we could say columns and rows. Each column is the index within the lists, and each row is the individual lists themselves. It's two-dimensional. So a matrix is similar to what we would see in Excel as a spreadsheet. Now, with that said, a matrix is an instance of a two-dimensional array. Arrays have a rule. They have to be the exact same data type. So if I have a two-dimensional array, these things all have to be that are stored in these lists that came into it, they all have to be the same data type. So if I pass one that's numbers, another one that's numbers, and one that's strings, we've got an issue. So with that said, should be good on what took place here. I created three lists. I passed them over to the Numpy array constructor. That function then created a two-dimensional array for me called sales matrix. And that matrix, here we printed it off, we see one row on top of another on top of another. If I said, you know what, I want to print off sales matrix 2, comma 2. Now, this looks similar to what I would normally do to access an item in a list by using the square braces to focus in on a singular index. A list has one dimension, so I only have to worry about one of the indices. But if we're talking about a matrix has height and width. Now let's see how this is set up. 2, comma 2. Well, we know because of the structure of it, we'll start out with 0. So this will be the third from one direction and the third from another direction. So that's this one right here. Now, let's do 1, comma 2 and see what it comes up with for us. Are we doing with height or width first? Let me do 0 actually. Do 0, comma 1. So, am I coming over here and going down 1? Am I coming this way and going, or am I going the other way? Ooh, we don't know. Let's do it the other way. Go 2. Started the wrong one. There we go. Three, 4, 1, 5. So an index of 0 and an index of 2. Index of 0, so if height is the 0 and I come down 2, I would be here. So it's not row first, it's going to be column first, or is it row first or column first? So we'll do this row, sales US, that row is 0, and go 1, 2. So there we go. So it's the row first, followed by the column. Now, if I put a 3 in there and run it, it's 3, 3, 3. Row, and move over to that index. What if I had 3, 0? What's going to happen? Out of bounds, because I don't have 4 indices to go through. Okay? So I'll leave that the way that it was. And so we can target a specific item within this 2-dimensional array. For me to do that using a for loop, it will require 2 loops, one nested inside the other one. I will go through item by item, one going, the first iteration would get me to the first row, I go all the way through it. Increase by 1, I go all the way through this one. Increase by 1, I go all the way through this one. So it's a nested loop that'll allow me to do those 2-dimensional data structure manipulations. Now, here's us saying what's from 1 to 3 and 1 to 3, and we see what that is. It's right here. 3, 2, 2, 1, 2, 2, 1, 2, 2, 1, 3, 3. So you see what's taking place there. From and to. what is the shape of this matrix? It's 3 rows, 4 columns. Rows, columns. Now, there's another term that can be used, and that is a grid. So we can have a matrix or a grid. Now, a grid is the same, conceptually same kind of thing. We're creating a 3 by 3 grid here, and just putting numbers in there as we go. And that's one way to do it. And because we are appending, we append onto it. Now, what is it that we've created here? Print, type, nums. Tell me what that is. That's a list. That's a matrix or a grid that we've created by using a list. I could do the same thing in an array. But what ends up happening, I'm not going to dig deep into it when it comes to an array, but in subsequent classes, if you're in C++ or you're in C#, you go on to data structures, you'll deal with these concepts in there where you'll want to do something with this data structure and you realize, man, the functionality is not there in a list class, but there's some functionality over there in an array that I can use. So let me go ahead and typecast that list to be an array, and then I can use that functionality. Okay. Depending on the language, lists may have very, very smaller functionalities available to you. When I say smaller, fewer functionalities available to you. Now, from here, I'm not going to dig much deeper. I'm about to wrap this up in the next 8-10 minutes. We dealt with strings. You know what a vector is? It's a one-dimensional array. Tuples, we just covered that. We haven't dealt with collections. Collections are something you will deal with in a data structures course. We've got a course, COP3530, on the bachelor's program, that will deal with collections. And we've got different types of collections. And we've dealt with some collections already in a way. And by collections, it's just pieces of data. We're collecting data and we want to store it in a certain way that it has some meaning, some organization to it. And then I want to navigate it to utilize it, to analyze it, to manipulate it, whatever it is I want to do. We've got 4 main types of collections: linear, hierarchical, graph collections, and then unordered collections. I've touched on arrays and grids. There's stacks and queues. Queues are something that people deal with all the time. We just don't realize it. Every time you stop at a stop sign or a stoplight, you're likely in a queue. There's somebody behind you waiting to get through it. So the first one to the stop sign is the first one out of the stop sign. Stacks are like stacking paper up on your desk. The last one you put on it is the first one coming out if you're going to go through them. We've dealt with lists. Beyond lists, there are linked list and circular linked list. We've got trees. We've dealt with dictionaries, sets. We've dealt with a special kind of set too. There's graphs, maps, file directories, hash tables, and heaps. Now I've got a link down here at the bottom of the workbook for you that will take you to another notebook that I've got. It's one of my data structure workbooks that here I'm in it, and it's something that I'm continually adding to. Once you have these links, as long as that notebook is there, you can access it. If you want to, you can pull down a copy of it. If I delete mine, you'll still have your copy. But with mine, they could grow. Over on the left, we showed you before, so there's collections, the types of collections, linear, hierarchical, graphs, and unordered. I've got them broken down by what linear collections are. Strings, arrays, lists, queues, stacks, links lists, circular link lists. Those are linear types of collections. Data stored in a line, one piece after another. There are trees. So you think branches coming off a tree, that's not linear. Graphs, and then we've got unordered structures. An example of that is a hash table. And I've got something down here at the bottom that'll be added on as I keep building and building and building on this course, and another course that I'm working on at the same time that shares some similar concepts. Okay, so that's data types, data structures. We've got structures, we've used them. You know, could you imagine the things that we can do in a spreadsheet if we didn't have a spreadsheet? How difficult would it be to perform the same tasks? We've created these structures, we've created these functions and these applications so that we can be efficient and get more done. You should be clear at this point on what mutable means and what immutable means. You know that an array is not built into Python, but in just about every other language, an array is. It's built in. Java has an array built in. C, C++, C#, that array is built in. Okay. I've got this broken down, and you can expand these out and go in and look at the different things. I'm going to talk about strings, and there's a help function. Give me help on string, and it will tell you everything that is built into a string. Here's all the methods. There's an add method, contains, and right on down. Okay. So I will see you in the next module. You'll have plenty to play with when I add different little pockets in here of, here, go try this, go play with that. And I'm going to add in some things that will be debugging, little challenges in these exercises to go find out what's wrong with this code and fix it. Okay. So I'll see you in the next module.